What is going on, Koda fam? Coming at you live on a Tuesday. It's not live, I'm joking. We are going to be focusing on some aerobic metabolism today. Last week we dove into the anaerobic energy system, and we talked a little bit about carbohydrates as they're the predominant fueling source, as well as the phosphocreatine system. Today we're going to be talking about fat and how that fuels this energy system in two different ways. So let's dive in, take a look at the slides. Quick reminder, remember last week we introduced ATP. That's the way that energy is stored. It's our currency. And we talked about the ways that, again, it was produced anaerobically last week. Today we're going to focus on aerobic production of ATP. And this slide should also look familiar. So we talked about ATP and creatine phosphate system, as well as the glycolytic system. And noticing that these primarily fuel, from an energetic perspective, activities who are shorter in duration. As we get into longer duration activities, which is most of what we do, both in terms of workouts as well as just day-to-day life, right? Anything lasting longer than 2 minutes is most things. And so that's going to be fueled by these different oxidative systems. And they have separate terms, but they are complementary as one feeds into the other. So, talking first about a concept called beta oxidation. So beta oxidation, we have fats that we consume in our diet, and those fats are made out of different fatty acid chains. And essentially, once they've been digested to the point that our body can absorb them, they get used as fuel throughout the body. And sometimes this means that they're stored as fat and later used as fuel. Sometimes it could be consuming actual free fatty acids that are floating around in your bloodstream after a meal. So they're transported into the mitochondria. You maybe heard this term. They often refer to the mitochondria as the powerhouse of the cell, as it's responsible for the majority of our energy production day to day. And so in this first step of beta oxidation, you can see in our little diagram here that fatty acids turned into a product called acetyl-CoA, and that undergoes a process called the Krebs cycle or the citric acid cycle, which generates ATP. You'll notice that this looks familiar based on the way that we actually break down glucose, right? We talked about our anaerobic metabolism last week, where we turn glucose into pyruvate. Well, that pyruvate can also be turned into acetyl-CoA and further broken down for additional energy. Our bodies are very efficient in that way. And then after that comes the oxidative phosphorylation process. So there's the electron transport chain, where we are then taking some of those byproducts of the earlier cycles, and again, through a process of donation of electrons, we are essentially going through a series of gradients that eventually result in the production of ATP. And we won't get into all the steps and all the enzymes involved, but I'll just highlight that this process, one, does take place in the presence of oxygen, as oxygen is needed for the reaction to take place. And it is the most energetically efficient system and the greatest driver of available energy in our bodies. So, that to say, I know there's a lot that we focused on with carbohydrates and manipulating those. There's less that we might do to manipulate fat, although you can be conscious of the types of fat that you eat at certain times in terms of their availability of fatty acids. So shorter chains, you might see something like MCT oil, something that might be available in like coconut oil. That's going to have shorter chains that are more readily available for digestion and entry into this process. A lot of what develops these systems is actually the training, not so much the immediate fueling, right? We've talked about how much fat we store on our bodies. Even if we're in our leanest of lean folks in the gym, we have enough fat to keep us going for weeks and even months. And so training these systems is aerobic training, and I want to say, like, the concept of going long. A lot of the workouts that we do, we might start off focused very hot and fast and trying to move quickly. And so we're actually kind of using and burning up those other energy systems, right? The creatine system is usually our lifting, and then the glycolytic system is usually fueling these interval efforts, like what we did yesterday in class, right? We did the dumbbell complex with thrusters, squats, and shoulder to overhead. We worked for 30, 45 seconds and then rested for 3-ish minutes. But as we train deeper and go down this rabbit hole of training our aerobic system, some things that happen are increasing mitochondrial density, right? So the mitochondria is where these reactions are taking place that produce the energy. So obviously having more mitochondria and more efficient mitochondria is going to result in better energy production, right? So if you think about it, if I'm going out for a jog and I'm jogging at a pace that is aerobic, which means my heart rate's not getting too high, I'm not burning through my energy too fast, and I'm working in what I would consider to be maybe a max aerobic power capacity, it means that my ability to produce energy internally in my body is being matched with my output and my pace of what my cardiovascular system can handle. And so through training, we become more efficient. So we're able to, we'll just focus on the energy system aspect. There is the ability to use the same amount of energy to complete more work, right? Someone who is a very efficient and well-trained runner might burn the same amount of calories as someone who's a very inefficient runner, and they might be able to go way farther with that same amount of calories, right? We also obviously improve our cardiovascular efficiency while we do this. So like I mentioned before, oxygen is required to make this reaction happen. So the more oxygen we can get available to our mitochondria, into our cells, the easier it will be for this reaction to not be limited in any way, right? And there's a lot of things that happen in our energetic reactions in these different pathways in our body where there might be a limiting step. And that limiting step is where we try to train to drive adaptation. We try to improve our capacity and our ability to use oxygen, to pump blood, to make energy happen, to make it exist. So I hope this was helpful, guys. Let me know what questions you have. I know this is a little deeper, a little nerdier, a little sciencier, but I think it is important for understanding the fact that our food and the way our bodies use it, as well as how they use the fat that we store, is a result of training and environment, and we can train and adapt to those different stimulus in a way that is advantageous to supporting our goals, right? So if you're someone who's looking to lose maybe some fat, it's understanding that aerobic training has to be a part of what you do. You have to spend time at lower heart rate zones for longer durations to burn fat, and pair that with the strength training and the high intensity training that we do in class. So today I want to hear what's your favorite type of aerobic training and how would you fuel an aerobic training session? Excited to hear what you guys come up with.